right on time. Got Brooke there, got the recording started. Awesome.
Good afternoon, everyone.
Good afternoon, good evening, good morning to some.
It's Maria, the Coral Reef Conservation and Management Program Manager from the Department of Environmental and Natural Resources in Puerto Rico.
Awesome, welcome. Yeah, we'll do some intros, try and get everybody on the same page of who we got here. And just here in a minute, we got a little activity to try and make that happen, so we don't necessarily have to call out everybody to chat. All right. So it's right at 2 o'clock now. Just to be respectful for all of you who showed up on time, we'll go ahead and get going. And I'm going to share my screen here real quick. And share, start slideshow. That'll pull up. Maybe. Well, it doesn't want to actually start the presentation. Maybe we'll just do it from the slide deck here. 2 seconds, make a few adjustments to my screen here. All right, is everybody able to see my screen? I got some nods, got some thumbs up. All right, awesome. We'll go ahead and get going. So what our normal or our agenda for today is pretty standard, what we aim for on these stakeholder meetings. I'm going to do just a quick intro to what the EIG is, what we intend to be, a few updates about what we have been working on, what we have going on. And then we have a quick introductions activity. We're not going to go around the room as we have in the past, so try and streamline that a little bit. Then we'll have our presentation from Astrid, and then go into some Q&As at the end for if anybody's got questions for her. So the EIG, or the Engineering and Innovation Working Group, our mission is to help connect engineering networks and coral restoration community in support of scalable and efficiency building solutions. And to date, we've had different attempts at trying to make it happen. We are continuing to try and improve and adjust that. We're working on a new draft, or I guess a new iteration of our overall goal and how we're going to approach this, that will be coming out and talking about at our next meeting. And then these meetings specifically, stakeholder meetings, are aimed at being, we're trying to do these at least on a quarterly basis, general meetings open to anyone who's interested to participate, to build awareness of existing and emerging tools and technologies for reef restorations. We try to use these to share high-level updates about the EIG, and then bring in a presenter of someone like Coastruction with Astrid Kramer that we're going to listen to today, or other new developing technologies or things that people have been doing forever, which, Dave, I think we should really have you give a presentation at some point. We should put that on our list of things to contact you about. Brooke, if you wouldn't mind writing that down to try and connect with him, because that would be a really great presentation for us to do for one of these stakeholder meetings.
Absolutely, Dave. I will be reaching out to you soon.
And we'll do some further intros here in a second, but I should have introduced myself to start out. I'm Miles McGonigal. I'm the current chair of the EIG. My co-chair, Deepak Satyanarayan, is on the call. Brooke is our secretary. And I'm sure we have a few others. I can't look at the list right now, but I just wanted to make a quick shout out to those folks. Then in terms of updates, just for those of you who aren't signed up to keep up to date with us, the CRC has a new website at crc.world, and we have a page for our engineering group there. And then those who attended Reef Futures Virtual, hopefully you got the chance to see the presentation that Deepak and I did about Coral Tech, which we'll talk about here in a second. But those of you who did not get to participate in the virtual content, it is still available. There's recordings of it all. There's some really fantastic work out there. I've got the link but it's also at the CRC website, crc.world, that you can all check out. And so to do our Coral Tech update, I'm actually going to turn it over to Deepak. I've got a couple of slides that he's going to talk through and give us some updates on, well, just talk about first what it is, but also when it's going to be available. So Deepak, I'll let you take the mic.
Perfect. Thanks, Miles. Yeah, so as Miles said, I'm the co-chair here for EIG, and we're working on this developing Coral Tech, which is basically an online database or catalog of technologies that we see internationally that are both readily available as well as in development for coral restoration. And so right around we want to build this catalog and solicit information from our international community through CRC, through EIG, to populate this catalog so everyone with coral restoration can have access and awareness of what's out there, from engineers, restoration practitioners, people in regulation, regulatory. So exactly who is Coral Tech for, right? So really anyone who's working in the space. If you're looking to use technologies, develop technologies, fund technologies, this is a resource that will help you figure out and help you make that decision. And so what we really try to do is categorize technologies, projects, and products along three main kind of pillars. One is technology area. That's really kind of the type of technology that it is. The restoration activity, which kind of details in the broad scope of restoration processes where that technology or project is applicable, as well as capture the maturity level technology, knowing where in the development pipeline it is, all the way from a kind of initial idea, like we think this might work, to it's actually in production, readily available to the users. And so any technologies that we put out there will be categorized with these three, and you can filter and search through whichever one is best suited for what you're looking for. So we're currently in development of this. We have a pilot RFI that was sent out a few months ago. We're working closely with the people who submitted to that, a small select group of groups and organizations that have technologies that we know that are being worked on to pre-populate Coral Tech. So by the end of this month or early April, we hope to have Coral Tech actually deployed and readily available for everyone, at which point we'll have basically an open solicitation for anyone else who's developing technologies or interested in technologies to submit their ideas, submit their projects, so we can basically showcase this to the international community and allow Coral Tech to be a real resource for our group here. Thank you. Feel free to reach out. The
Awesome.
interest link
Yeah.
that's there. That's definitely a place to connect if you're interested.
Yeah, and I just sent out that link. Once we do go live with Coral Tech, we're going to be, anyone that signed up on that Coral Tech interest form there, we're going to be passing, just making sure everybody's aware of it and that it's up and live and available for others to start adding their own entries to Coral Tech. And so if that's something you all are interested or have questions about, fill out that interest form or reach out to myself or Deepak separately, or just offline. We'd be happy to answer any questions about that. So then our next point of the announcements, just always looking for suggestions for presentations, topics, or anyone that could be a presenter like Dave for these meetings. We really want this to be representative of an opportunity to connect and learn more about what does exist out there in our space and help to just build that awareness. So if you do have ideas, reach out to Brooke, her email right there. And then lastly, if you're interested in getting involved in helping us out, we're going to be rotating Brooke out of the secretary position here in the next few months, and we're looking for someone to take over her role. So if you are interested in that, please reach out to me. I can send the requirements, the kind of commitment descriptions and everything to you for you to be aware of. And so now we're going to do an introduction activity through a platform called Mural. If everybody can jump into the chat, I'm going to post this link. It will give you access to this mural board here. And in here, what we want to do is have everyone jump in. You should be able to just join, click on that link, and you will now be part of this board. And what we're going to do, of course, I don't have my actual mouse set up. I knew I should have done this. So what you're going to do is on this board here, you can zoom into it to your location of where you're at. And then you can either double click on the board here to create a new sticky note, or you can click the sticky note button over here, select a sticky note, and we want you to fill in those notes with your name, the organization that you work with, your job title, and what excites you about the EIG, or what brought you here today. Why are we here to join? And we really want to do this as a representation of, who all do we have on this call, but also the locations in the world that you are jumping in from, so we can get a better idea of who all we have, and just, in the past, we've gone around the room and had everybody answer a silly question, but also tell about where you work, what you do. And so this is just a way for us to get a little bit of information without having to all jump on and go around the room. And hopefully this is maybe a little bit speedier, but an opportunity for everybody to see all these cool people that are on the call, and the influence and localities they're coming from. And maybe it's people that you don't even know are working in your area, or working in an area you would like to be in. So we'll give everybody just a minute to jump into that. And I'm excited to see what this does look like. I'm imagining don't have too many people from us. Don't have too many people from Australia on the call today, because it would be about, let's see, it would probably be about 4 or 5 in the morning there. So maybe don't have too many of those. Yeah. Daria coming from us from Iceland. We do have somebody that is not muted and yelling in the background. If you wouldn't mind muting yourself, that'd be great. Few people from around the US. It's like maybe we got some Bonaire folks on the call. Awesome, great to have you all out here. Got some nice scribbles on there too. That might have been my fault. Saudi Arabia. Excellent. Well, and so I'm going to leave this as a resource for us all to maybe take a look into and have as just some reference. Also, people that you could reach out to or chat to privately, or we can, in the question and answer section at the end, if we get finished with all of that, maybe ask some questions about these localities. But I do think this just gives us an excellent opportunity to see the amount of people that we have interested and willing to be present in this space, in that search of building collaborations throughout the coral restoration community, and those that aren't directly involved in it. And so with that, I'm going to go back to our slides over here, and I think that was actually all of our slides. And so with that, I'm going to give up my screen share potential, and gonna, Astrid, if you want to go ahead and jump into the screen sharing. I was gonna try and do the intro to Astrid, but I do think that she's going to be able to do it better than me. Unfortunately, I do not know Astrid well enough to give an excellent intro. So I'm gonna let her tell you about herself. And if you can go ahead and get into the screen share, Astrid, there. Let me know if you're having any issues.
Astrid was having trouble seeing the sound from hearing the sound from the presentation.
Oh, shoot. Okay. Wait, she may be unmuted now. Nope, she's still muted.
Yes, hi, sorry. I needed to get out of this screen.
There we go.
Hi, let me start to share my screen.
Okay, there we go. Awesome. And then for the person that asked about the recording, yes, we will be sending this recording out after this call for anybody that is not able to be here or is having technical issues. But we will definitely be sending this out. And Astrid, the floor is yours.
Thank you so much, Miles. Well, hi, everybody. Good morning, good evening. This is Astrid from Coastruction, and we're a startup based in Rotterdam, the Netherlands, and we're 3D printing artificial reefs. Let me see. Why does it not use my? Yeah, so the startup, we started officially last year in December, but we've been working on artificial reefs already for quite some time. I started the company together with Nadia Fani. She is an Italian computer engineer with a, I think she could be seen as one of the experts in 3D printing of concrete with powder bed technology in the world. She knows a lot about the materials. So if you have any questions on materials that I cannot answer, I'd be very happy to get you in touch with her. Today, I wanted to talk, of course, about 3D printing, but most of all, I would love to share ideas with the applications, on the concerns you have, on possible collaboration opportunities. So feel free to interrupt me at any time during the presentation, or if you want, you can save your questions for at the end. So my background is in marine ecology, and I have worked for a maritime contractor for 15 years, traveling all over the world, doing dredging and reclamation projects, and then the environmental aspects of that. So a lot of monitoring, environmental mitigation, and at some point also coral relocation. We were working in Jamaica in 2009, 2010, when we had to do the biggest coral relocation, I think, at that time in the world. We had to relocate 150,000 colonies of coral and also placing artificial reefs. And at that point, I started to get fascinated by artificial reefs and looking into all the different forms that were there, talking to a lot of people of what would be the best design, the best material for our project. And that's when I also got in touch with Enrico Dini, who was the founding father of 3D printing in big dimension in concrete. His company D-Shape 3D printed the first reefs, I think, in the world, and they were placed in Bahrain by Reef Arabia, by David Lennon. And I started to get really fascinated with 3D printing. So I presented the idea in an innovation challenge in the company I used to work for. And I thought, how cool would it be if we need to dredge somewhere and we make a damage to the environment, what if we could use the material and 3D print it into a hard substrate and use it to speed up recovery if we have to do that? So we got some budget to test on this, and one of my colleagues got in touch with Prince of Monaco Foundation in Monaco. And they said, yeah, we have a location where you can install the reefs and we'd love to collaborate with you. So that's where I met Nadia. We worked on this project together for a year. And these were the first reefs we printed together. They were designed for different species that were selected by the divers, by the stakeholders of that marine protected area. And we looked at the habitat characteristics, the habitat needs for these species. So there was octopus, there was grouper, there was shrimp, but there was also benthos. So you can see in the design in the bottom, there was some holes in the structure, and that was for the benthos, for the animals to get out, so the footprint of the reef wouldn't be damaging the life in the seabed. So then after that, we got an assignment from the World Wildlife Fund, still working for Boskalis, for the marine contractor, to print oyster reefs for the North Sea. So we did that in collaboration with Reef Design Lab, with Alex Goat from Melbourne. He's an amazing designer. and he designed these reefs, and we 3D printed them. They were installed in 2018, or yeah, 2018, and yeah, they were being monitored every year, and already after a year there was a oyster spat on them. So they're doing really good, getting stronger every year. So after that, I left the company, and at some point Nadia contacted me and said, do you want to start this company and build our own 3D printer? So I said, yes, of course, I'd love to do that. It's amazing technology and it has so much potential. So we're, we started the company last year, and we defined our mission, and that is to build 3D printed reefs for coastal protection and habitat restoration, even in the most remote places. And with that, we want to inspire people to achieve also a sustainable relationship with marine ecosystem and make concrete circular and more eco-friendly, because concrete is, of course, one of the biggest contributors to climate change. And we wanted to explore if we can use it, but then in a more sustainable way, and see if we can use replacements for the cement. What was important to us is that we've seen a lot of artificial reefs in the world, and some of them are very beautiful. They blend in very well with the environment, but there's also a lot of them that I think how Nadia would explain it as extremely ugly. And of course, it's always the function that they have. They should do what they're designed for. But we also see that there's amazing shapes out there that have withstood the test of time. So why reinvent the wheel? So we came in touch with Carlos Ligo, and he's a beautiful designer in Lisbon, and he uses a biomimicry design. So he helps us to see how we can include natural shapes in these reefs, and collaborate with him and with other people. So our strategy is to 3D print reefs in collaboration with local stakeholders, use natural forms, use natural materials, and always search for the lowest CO2 footprint as possible. And also, we think it's very important to keep researching the application of artificial reefs, and collaborate with knowledge holders, local knowledge holders who know their area best, and see how we can jointly come up with designs. So a little bit about the technology. We use powder bed printing, which is not extrusion printing. I think there's the biggest, there's a big difference between the two technologies. Extrusion mixes all the materials beforehand, and then almost like a can of whipped cream, you spray layer on top of layer. We use powder bed printing, and I hope everybody can see this. Is a small demo. And
I can see it, Astrid.
Okay, great. So we use a printhead that moves across a bed of a mix, and usually that mix is sand with cement. Cement is the binder. And then we selectively deposit water as an activator on the cement. The water creates solid areas in the mix, and after the layer is printed, the print bed lowers. So over time, you build up your structure. The result is a block of loose powder with the structure inside. So for post-processing, the part will be freed of unbound material, but this material you can reuse again. So there is no waste. If the structure is not what you like, you could crush it and use it as a filler in the next print. So therefore, there's no waste in this. The ideas that we have is that the technology has freedom of form. When you look at reefs and you see caves and overhangs and this really complex structure, this is something we can replicate. We can make this, because when you have your layer of printed material, the next layer is laying on top of it. So you always have your support for your structures. In extrusion printing, this is a little bit harder because you need your material to harden. And if it doesn't harden fast enough, it will collapse when you print an arch or a cave. And that is why a lot of times in extrusion printing, they add chemical additives to speed up this hardening process. Well, we say that there is already problems enough in the ocean, so we don't want to use chemical additives, and that's why we print with water or seawater. And another option is that we print with carbonated water to capture the CO2 in the cement. This is something we've done, and it works. And now the next step is to quantify how much CO2 we would actually capture. So the technology, the printer that we build has freedom of material, so we can use local sand or dredge material, fine material. Of course, the strength of the structure depends on the combination of your binder and your aggregate. We ship the technology instead of the product. Therefore, we are designing a printer that fits in a container and that is self-supporting. It's a fully automated printer, so it feeds the material, and basically the operator sits next to it to supervise the process. But during printer, he doesn't need to do anything. Because of this technology being quite user-friendly, you could train your local staff and print the structures. You design what you want to do, and then you feed it to the computer, and then you print it. So what we have right now is a printer that is quite small. It's called Edifix. But this printer allows us to test all the different parameters, so the use of water, and with that, how much water you use is important because it determines your resolution. So we can print now with a resolution of 2 millimeters. A lot of times it's not necessary. When you have big reef structures, you could easily go with a resolution of maybe 1 to 2 centimeters. But if you really want to do fine stuff, you can use a 2 millimeter. Of course, it goes slower, and in the end, it will also be more costly. So we have Edifix up and running, and we're now finalizing the design for Asterix. Asterix will have a print capacity of 1 cubic meter. And after that, after we've tested it, we will go for Obelix with a print capacity of 6 cubic meters in 4 hours printing time. But of course, there's a whole lot of R&D steps in there that will keep us busy. Well, this slide I'm just going to skip because it's basically a recap of what I just said. We see applications for these type of reefs near shore. Since we can print any form, it could be fun to print beautiful reefs that are also attractive for tourism, for recreational divers. And of course, for coastal protection, we can print any shape, so we can optimize the design for wave reduction. Offshore reefs are also one of the target markets that we see here in the Netherlands at the North Sea. There's a lot of windmill parks coming up. They're using anti-scouring materials, usually just rock that is quarried in Norway or somewhere else far away. But it would be very interesting to see if we could print with on the vessel with local material and place the reefs right there after printing them. And of course, another structure is the breakwater structures. This one I'm just gonna skip for now because I love to get some interaction at the end of the presentation. We're constantly looking for parties to collaborate with. We have a collaboration with the Hawaii Coral Restoration Nursery. They're testing some of our materials for larvae settlement and coral growth. We have some samples in the water in the Seychelles. We're also collaborating with the Horniman Museum in UK and University of Derby, also looking at coral larvae settlement. Here are some of the results that we have. The colonization of crustose coralline algae that you can see in the middle. That's a collaboration we have here in the Netherlands with the Young Marine Life. Yeah, and the left picture is a coral larvae settlement from Hawaii. And the right picture is one of our pucks that we printed just to see how they were doing in the Seychelles. Yeah, one of the questions we always get, of course, is like, how expensive is it to use these 3D printed reefs? It depends on a lot of things. So the machine, is a user leasing it or buying it, or do you want us to come over and print it for you? What type of designs do you have? Are you making them yourself, or do you want us to make the design? What materials are you using? Is it local material? Are you using recycled concrete? Yeah, are you printing yourself? You have your own staff. The transport, which country does it need to go to? Is there a print facility, or do we need to print outside? How many modules do you need? And of course, like, what is your timeline? So there's a lot of variables that depend the price of this. But our estimations are that we could print, when you have like a big project, you could print roughly a cubic meter for $500, which is not that much more than I think than traditional cast or concrete. But and then you have all the added extras for the complexity and your ecological value. One of the things I like to do myself is to work with school children. And here in the Netherlands, we of course, we're below sea level, so we have a lot of risk of flooding. And of course, the rivers and the river banks, they're all covered in protective measures. Usually they're quite homogeneous and they don't have very much ecological value. So yeah, I'd love to talk to the kids and say, how do you see your coastal protection, and make them work in clay to get something. We scan it and we print it for them. So that's something we would like to elaborate on. This is basically what I wanted to tell you. And yeah, I'd love to hear your feedback on this.
Right. Yeah, thank you so much, Astrid. I just wanted to say, for anyone who has any questions, there is a reactions button at the bottom of the toolbar where you could click on it and then raise your hand. So if you have any questions, I'd recommend doing that.
And do we see then the hand somewhere?
Yeah, if you're able to look at all the participant list, you can see who has like pressed the raise hand button.
Okay.
So yes, if you're able to. Yeah.
Oh, I see a hand.
Yeah, that's my hand. I'll lower it. You have
There
a
you go.
Dov.
Nadav, looks like you have your hand up. Go ahead and unmute yourself there.
Yeah.
Go ahead.
Yeah, thank you. And a great presentation, really exciting. And I was actually wondering about when will you be able to start shipping your systems? We actually do have a project. The money should be coming in this summer. So we have to decide which printer to use. So it sounds like a possible match.
Yeah, that could be very interesting. Well, we're finalizing the design now for the asterisks, for the 1 cubic meter.
Mm-hmm.
Once we have also the money for that, which is, of course, money is always a problem. But we're looking at some big projects that might realize that. We will need probably 5 to 6 months to build it. So then you're looking at towards the end of the year that we have it ready.
We should talk about it.
Yeah.
Go ahead, Joaquin. You got your hand up.
Sure. Thank you so much for the presentation. Really, really nice. Here we in the University of Illinois, we are working in materials for new substrates, and they are based on kind of cement, limestone, and all these kind of things. And we are trying to implement some additives on them. And I guess that the final idea would be printing them. So I would like to ask you first, which kind of compositions are you working with? Just normal cements or regular cements, or the ones that you mentioned, which are from recyclable or something like that?
Mhm.
And also, have you tried any other systems besides from cement, or ceramic paste or something like that?
This would be a perfect question for Nadia. She's the material expert. What we usually use is we print with either aragonite sand or dolomite sand or beach sand, and then we used for the pucks that we're studying in Hawaii, I think it's called SEM3. But there's a difference, because in the US it's called, I think, SEM3, and here it's SEM2, but it's like, we call it marine cement.
Right.
That's what we're using. But yeah, we have also used Sorel cement, different types of cement. But if you're really interested in the different possibilities, sure, I'd happy to introduce you to Nadia.
That would be great, because yeah, sure. I can talk to her a little bit more. Yeah. Because another thing that, are you able to design the ink or the paste that you are going, the final cement? Because as you mentioned, depending on the amount of water that you put in the cement, you will have differences. So are you able to do this study of see which is the proper value of water inside of your concrete?
Yeah.
Okay, cool.
Yeah, so usually what we do is, because we have very fine valves and nozzles, we know exactly how many milliliters of water go in on the bed and how far it sinks in. So then you know what is your range and how much water you use, because it soaks in the material.
Great.
So yeah, we that's why we built also this printer in the way we did, is to control each variable. And also play with it, so you can change every component of the recipe.
Thank you so much.
Yeah, you're welcome.
Go ahead, Eleonora. Get your hand up.
Hi there. This is Eleonora from the Red Sea Development Company in Saudi Arabia. I was wondering whether you have tested the hydrodynamics of those structures. One of the key issues that we're having here is that we're working in very shallow areas with quite a lot of currents in some certain areas. And as a result, some of the structures get carried away. Or we're afraid of that and we want to avoid it. The other thing is that we're trying to avoid materials that erode easily, and as a result, that could lead to contaminants. So far, we're trying to use existing material from the site to cover our core relocation needs, but that's not enough. So at some point, we'll need to accept new options. So that's the one that you're discussing, but the authorities here are very sensitive in introducing like cement structures into the environment that may erode and then disperse contaminants or additives in the local ecosystem.
Yeah, so yeah, your two questions. One is about the currents. We can print any reef, so we could print a reef ball, or we could print any shape, and with that we're 100% sure we can reduce waves and create stable designs. Of course, you need to study the wave climate, the currents, and design for that. We are now starting up a program together with Deltares. They are connected to Delft University here in the Netherlands, and they're quite big on hydrodynamics and testing them. So we'll be testing in one of their wave flumes in May or June, hopefully, and a complex design. But each location is different. So you'd have to look into it and see how you can design your structures to be stable. And your second question about the materials, yeah, we don't use additives, so that means also that some of our structures will be maybe not as strong as the ones that you use additives with, but you could reinforce the structures with natural materials. So either with when you use a lower resolution. So maybe you have like a resolution of 1 or 2 centimeters. You could use gravel to reinforce it. And then of course your weakest point will be like at the layer where they connect, because there cannot be any gravel in there, but the layers will be super strong. And then you can use the natural materials to fit it. But of course the cement, yeah, you probably will use that. So if that's already a tricky part, then I don't know, you'd have to look into other materials. I think that's also another question for Nadia.
Thanks for those questions, Aurora. I wanted to kind of follow up on one of those points she asked about. Is there like a standard attachment mechanism once you have the unit printed? Like how do you typically plan to attach these to the reef after they've been fabricated?
I have a little bit of problems like hearing you, but if I understood correctly, your question was, how do we attach the structures on the seabed, right?
Correct. Yeah. Is there a standard mechanism for doing it?
Well, the structures that we printed before, that was before we had Coastruction, but when I was working for Boscalis, the structures we placed in the Mediterranean, they were 2.5 meters in diameter and over 1 meter tall, so they weighed almost 3 tons. They were not attached to the seabed. The ones in the North Sea for the oyster reef restoration, they were also not attached to the seabed because they were heavy enough for that depth, for that climate. But what you could do is, if you need to attach them, you could, like in your design, keep a space for a rod or bolts or, yeah. But we haven't done that yet because the prints before were so big that they didn't need anchoring or anything. Another option is to work in modular designs, like a Lego system or like a bolts and nuts, or we have tested that before, but not in the field.
Okay, thank you. Dwayne, I think you're next.
It's almost like I hear 2 people talking, but that's not possible, I guess.
Yeah, I'm actually hearing the same thing, but everyone's muted. So
yeah, I only see one.
That is. Yeah, I'm not sure what that is.
It's probably where I'm at, that it's just loud here.
Okay.
But Dwayne, you're next. Brooke, do you want to go ahead and call out the people with their hands up so I don't have to confuse people?
Yeah. Next up is Dwayne. Dwayne, are you there? If not, we've got Colleen in the queue.
He's got his question in the chat.
Oh, got it.
If you want to read it off.
Sorry, let's see where it is. Oh, no audio. Okay. Does your technology support the creation of dissolvable structures? In our case, we'd like to create a support structure that will dissolve after 2 years. I'm very excited about the technology and love to chat some more on a smaller scale project supporting oyster restoration efforts in Maryland.
Yeah, sure. You can do anything you want because you have freedom of material. So you could look at your recipe and make sure if you have like currents or waves to make it erode in a specific amount of time. You can design for that. Either in the shape, so you can make it thinner or weaker, or you use different ingredients. But you have freedom of form and freedom of material, so you can do anything you want. I hope that answers your questions. And yes, I'd love to. We could chat on the oyster restoration project if you want.
And maybe if you want to drop your email address back into the chat, Astrid, to just for everybody's reference, that'd be helpful.
Yeah, sure.
Yeah.
Colleen, you want to go ahead?
Oh yeah, sorry. I just was realizing, thank you. Actually, a couple questions. If people do, I had trouble, I had trouble getting my little sticky note thing, but if there is a way, some of you guys are asking questions like, do you guys have a way to share the emails? Everyone, like Dwayne's question seemed like something I would want to follow up. I just realized there's layers, but the thing, did you ask, were you asking how to glue on or attach the corals once the structures are attached, or were you asking Miles about attaching it to the seafloor?
I was asking about the seafloor.
Oh, you were?
Just,
okay.
Yeah, exactly.
Because what I wanted,
real quick,
I wanted
with respect to contact info, as long as everybody's okay with it, we can share it. But I think just in general, we don't want to just like broadcast everybody's contact info out just in respect for everybody there. Maybe if that is something you want to share or you would like other people to reach out with, we could you could either contact Brooke or myself or send a message out in the chat just asking people for their contact info. You can do direct messages in the chat too, so you don't have to send it to everybody if you don't want to, just to be respectful of everybody if they do or don't want to share.
Yeah, yes, I'll do that. And I wanted to, so the question or the thing for Astrid is somebody to contact. I'm working with Dave Schmidt with Muscle Polymers, and I'm not sure if you guys all know him, but he's working on using the biomimicry or the same synthetic, it's like a synthetic version of how mussels are attaching. And what would be really cool, I can tell, is your surfaces, you don't always want to have holes, or how are you going to attach the corals if you're using it for corals and you want to be able to like propagate, like Dave Vaughn here's like his microfragments. And we're going to be testing it, I think in April, but it seems like a really cool, you can use it for, again, with metal in the sea, you can use it for ship repairs, and you can use it so it would be almost like another way to add a layer for helping to sell, like how do you attach the corals to it with a glue that's not like epoxy. And I've heard you just use a syringe or something and it quickly like affixes and it lasts. I don't know, I'm really excited to test it out, and I think it would be a really cool thing. It's called Muscle Polymers and Dave Schmidt. And if we share messages, I can connect you to him. I'll send it to you.
Sure. It would be so interesting. Like we could send one of our pucks with different materials, and then he could test the material on the structure. That would be an option. But yes.
Oh yeah, you could send it to us. And the other thing is we're working with making biodegradable or that's why Dwayne or whoever was asking, that we're working with some sort of materials too that have some possible properties of dissolving. So I wanted to talk to you more so we could try to factor in what you want, because all these things are possible. Like that's one of the things about these meetings is I get really excited. Like, how do I, I'll send direct emails.
Great, thank you.
That's great. I love hearing that. Please connect us. And if you all want, you're also welcome to put that contact info on those sticky notes on the mural board. Just to
I failed at the sticky board. Okay.
I'll send the link to it out again if you want to try again, but otherwise direct messages in the chat here is great. And if you don't get a hold of people, reach back out to us and we'll do our best to connect you.
Okay, thanks. Okay, I'm taking screenshots. I'll get out of here.
No, absolutely. I mean, like our main objective with these stakeholder meetings is for everyone to connect and to find these opportunities. So definitely direct message people, send out your contact, and make those connections. Do we have any more questions? Yeah. I don't think so. Oh, actually, yes, from Pear.
Oh, you said it right too. Are there any questions, or sorry, are there any differences in molding versus extrusion, and then the form of printing that you use in terms of strength and benefits and things like that?
Yeah, well, I think with molding, you pour the concrete in, you mix it and you pour it in. I think it's when you do it well, it's the strongest. But of course your form is limited because you have to get it out of the mold. With extrusion, extrusion is probably the fastest one, although it's also limited. But yeah, I think the powder bed printing that we do is you can get the most complex forms. So in complexity, you have casting, extrusion, and then powder bed printing for complexity of your structure. I don't know, what else did you want to know?
I was just wondering, because I know that there's the two different types you were mentioning about with 3D printing, and I wasn't sure if there was, any pros or cons. I'm not an expert in 3D printing, but it seems like definitely with versus molding, you couldn't probably get the cavities, but between the two types of 3D printing in particular, what were some of the benefits? Or...
Yeah, well, if you have just 1 second, I'm going to show you something that we think when we talk about complexity, then this is what I see, and I'll just get it like in 1 second.
And while she's getting that, I think a really important thing to recognize just within that 3D printing world, and this is probably a presentation we could bring in as is there's so many different options of 3D printing techniques. There's not just the two that Astrid mentioned. And then the amount of different materials that you can 3D print, but then the effectiveness of the different boundary boxes that you can print in that those specific types of 3D printing can do. And so, there ends up being a lot of conversation around 3D printing and coral restoration at this point in time. I've been noticing it just more and more and more. It's increasing year over year, but our understanding of it is there's varying different levels and different opportunities within each different type of printing mode. And so it's just important to recognize that not one size fits all in that spectrum, I guess.
Yeah.
Yeah.
Yeah, I think okay, I don't know if you can see it, but this is the reef that we printed for Monaco. And you can see all the way through, like this is the top. You cannot do that with casting, and I don't think you can do this with extrusion because it's way too complex.
Yeah, that's very high detail.
Yeah. So this is, when we talk about complexity, this is what we like to do. So you take every form and you just combine it into one structure. You can do whatever you want, but
and you're not limited by I guess what would attach, like in your formulas. Do you have to use different? I know that it sounded like you said you could use basically any formulas with that the printing technology, but I wasn't sure if using that water-based technology limited you in any way about what kind of formulas you could use.
Yeah, well, I think the strength of the structure, if you want something like in a very dynamic area, when you have like 10-meter waves crashing onto something, you want something super strong, like 50 MPa. We cannot get that. So in your really high dynamic areas, you want to get something, but then I think you're looking also at chemical additives to get that strength of 50 MPa. And then you need casting or extrusion. Yeah.
Okay, thank you. Very interesting.
Okay.
So just real quick, I know that people have to probably got to get moving in the near future. We got about 6 minutes left. No, we still got at least one more question here, but just want to thank everybody for joining. We will be broadcasting out once we have the video recording up, and we will keep everybody updated. If you're not on our listserv, which if you're on this, if you got the invite to this, you're on our listserv. So, but if you're not, reach out to myself or Brooke. We'll be happy to get you hooked up. And just thank you all for your time. Thank you, Astrid, for the presentation. And so just to give everybody the green light to leave if they need to. Ottawa, you just took your hand down, so I don't know if you have a question anymore.
Sorry, I thought I'd run out of time.
Oh no, we got time for you still, absolutely. I just wanted to get everybody the okay that, and thank you for joining, and then we can just use the rest of our 6 minutes we got left for questions.
Gotcha. All right, well, thanks, Astrid. That was really interesting. And so I'm a coastal engineer and did my studies at Delft as well, so I'm familiar with Deltares and the whole building with nature concept that is heavily taught there. And I guess one of the challenges that we run into a lot as coastal engineers is 99% of our clients come to us looking for wave attenuation as their primary goal. And the ugly stone breakwaters are very cost efficient at doing that. And so we really like to try to incorporate, whether it's, working with David to put something more interesting on them or build them differently, or, we like the look of these 3D structures, but we find it hard to convince the client to pay the premium for something that looks nicer, but kind of has the same performance. So I was wondering if you or if anyone on the call kind of has any good references that help to justify the additional benefit beyond wave attenuation for these structures.
It's a very good point, and yeah, we've noticed this as well. First of all, I had a talk with Gonzalo Gonzalez from the World Bank a few weeks ago, and he has, I don't know, maybe some of you know him. He has made an overview of different types of artificial reefs and hybrid reefs, like the combination of traditional casted concrete or X blocks or big rock, in combination with more complex reefs for a project in Seychelles, I think it was. So he's really working on that in a business case, and his report will come out in May. They're publishing it now, so that he probably said May. So that's one of the first attempts that I've seen where people really making the business case and putting a financial value on these 3D printed reefs. But other than that, yeah, we're also struggling with that.
Yeah.
But maybe somebody else has ideas.
Yeah.
Yeah, if I may jump in, couple of things. One thing about complex reefs, or things that you must know, you probably know the project of eConcrete, which they put in. It's not 3D printed in any way, but they have structures that actually are added into coastal defenses. And now we are trying to do something else, and that is to add, to replace specific blocks of in traditional types of coastal defenses, and see how much that will add. So you don't need to replace the whole thing, but every few meters to put 1 or 2 units and keep on going like that. And well, it's pretty new, but the results so much are quite encouraging.
Yeah, that's good to know. Yeah, we know eConcrete. They're well known. Okay.
Well, recognizing that we're 2 minutes away, I think we should probably call it here unless somebody's got one more quick question. But again, thank you all for joining. And I think we've got a few more things to follow up on, and we will aim to have we're aiming for, as we said, one of these meetings at least each quarter. We'll do more if we have more presentation topics, a lot of interest. So it's something you all help us define exactly what we're going to do and how we're going to do it. So it's your motivation that helps us keep trying to coordinate and organize and make these meetings happen. So just let us know any feedback you might have there, potential for new presentations, topics you'd like to hear, and we can hopefully try and make some of those things happen. But thank you all again for your time, and we will talk to you. We'll see you next quarter in the next couple of months. Thank you all. We'll talk to you soon.
Yep.
Thanks,
And
bye.
one last thing, guys, we are looking for a new secretary. So I know Miles mentioned it at the beginning, but if you're interested, definitely send him an email, or if you just want to be involved in the EIG in general.
And I'm sending out my email address right now in the chat.
Mhm.
Take care, everybody. Have a good afternoon or evening or morning, day, wherever you're at. Cheers.
Thank you, guys.
Bye.
Bye.
Just screenshotting all these.
Bye, guys.
Bye, see you.
All right,
Thank you.
take care.
Astrid.
Bye, everybody. Thanks.
Bye-bye.
Bye. Okay. Bye, guys. See you all.